My project is a modular artificial coral reef. The reason for this project is the coral reefs are disappearing. They're disappearing at a rapid rate due to climate change and pollution. And this is an issue because reefs house 25% of all marine species, which is a lot. Artificial reefs are one of the solutions we have for this. They're structures designed for coral reefs to grow on. One of the coolest examples of this is ships are purposefully sunk so that coral reefs can grow on them. But we also have carved rocks called reef balls, which are more similar to my proposed idea. A disadvantage of these structures is that they only provide place for reefs to grow. They don't bring any coral with them. And the reason for that is later in the presentation. And another issue is that they aren't very scalable. My project attempts to address both of these issues. So it's a modular system for artificial reefs. You print a bunch of copies of one piece that is designed to fit into itself and snap together like Legos. The secret behind that is that half the faces are plugs and the other half are sockets. And they are arranged in such a way that they can be combined together infinitely and in a bunch of different configurations, so they can tile forever. Other people have tried modular artificial reefs, well, actually, only one organization I could find has tried it. They're called Mars, but they use a cube tessellation, which is less efficient than the rhombic dodecahedron tessellation that my system uses. The cube tessellation also means that they require at least 3 distinct parts to be printed. At least in the pictures that I've seen, they require 3 distinct parts. They could require more, because I'm not fully sure what's going on inside of each individual node. And the rhombic dodecahedron is actually based on hexagons, which is why we have a little b there calling the cube tessellation inefficient. It means that more surface area for coral to grow in less volume. As for the other issue that my idea addresses, which is that existing artificial reefs don't bring any coral with them, the solution to that is tissue culture transplanting, which is a common process in plant horticulture, where you clone cells and you transplant them in a new location. This used to be impossible for coral because it's actually 2 organisms living in a mutualistic symbiosis. However, as of 2021, a method for creating coral tissue cultures has made significant progress, and I'd like my project to take advantage of that. I have not seen any other modular artificial reefs include tissue culture transplanting. Each vertex of each rhombic dodecahedron contains a slot for the tissue culture to be placed. That way, instead of just waiting for existing coral to grow on them, the artificial reefs introduce new coral that speeds up the process. To create this, I used Blender to create the model, and then I 3D printed it. Before printing, I split the model in half. That way it would be easier to print. However, in the middle there, you can see what would be 2 cells of the artificial reef. This also allowed me to show off more configurations, so the top right is how 4 would fit together. The models don't snap together as well as I hoped they would, but that's to be expected with only having 1 print to test. I made the connections a little bit looser because I didn't know how accurate the 3D printer would be. Turns out it was very accurate, and so I made them a little bit too loose. However, overall, I'd call this project a success. All right, thank you.